Hello, hello. Welcome to another live session with Nerdot regarding Microsoft Fabric. Good morning, good evening, good afternoon to everyone. And yeah, I'm very excited to start the second session. So just wanted to say thank you for all of your positive feedbacks that I've received from you guys regarding the first session. Everybody likes it, and yeah, it gives me more energy, and actually it motivates me to continue stronger. So let me share my screen and see what we have for this session. My name is Merad Abdullahi, and I'm your instructor in this journey with Microsoft Fabric. So if you would like to join the LinkedIn group that we've got in the for learning Microsoft Fabric together, you can just feel free to scan this QR code and join the group. And there we can chat more. We can just use each other's experience, and we can share our knowledge, share our progress. And let me bring it up. Hey, so yeah, as I mentioned, we have completed the first session on May 25th, and today is the second session on 29th of May. And we are still in the build challenge, and we will stick to that for 8 sessions that completed within a month before June 21st. And so if you haven't watched the previous video, feel free to watch it. It is already uploaded in YouTube channel. And yeah, after these 8 sessions, we will continue to learn more about Fabric and whatever that is required for just mastering DP-600 and prepare for that exam. So in session number 2, we have Apache Spark in Microsoft Fabric. And the module that we are going to cover from Microsoft Learner Learning Path is use Apache Spark in Microsoft Fabric. What we are going to learn today is basically we are going to learn how to configure Spark in Microsoft Fabric Workspace. We will identify the scenarios for Spark notebooks and Spark jobs. We will use Spark data frames to work with data, analyze that, and transform that data, save that data. And we will also use the Spark SQL to query the data in tables and views. And also, eventually, we will visualize that data in Spark notebooks. So what is Apache Spark? Apache Spark is an open source distributed and parallel processing framework that is basically built for large, scale data processing, actually larger scale data processing and analytics. It is very popular for processing the big data. And what is big data? The big data is basically refers to the volume of data that is in in a size that cannot be dealt with in traditional modes, that we cannot process them in one computer, and the work has to be spread to a network of computers, to the nodes, the cluster of computers. So some examples of big data can be the data from banking industry, or even the data that is related to the socials that we have more than, for example, 100 million or 1 billion accounts there. So it is a big data. It cannot be stored in one database. It has to be spread it out in the network and be processed in that way. So Apache Spark in Microsoft and in Azure, platforms are available in Azure HD Insight. We have it in Azure Synapse Analytics and also in Microsoft Fabric. How it is going to work? How does the Apache Spark work? So we mentioned that it is a distributed data processing framework. And of course, the data is going to be distributed and stored and processed in cluster of nodes. And it is going to use a approach which is called divide and conquer. So it is going to spread the work to the clusters, and after that, it is going to wrap them up and get together all the results in, and it is going to be stored or processed within the computers, and there is a manager for all of those workers and jobs. And the languages that we can use in this framework are basically Java, Scala, which is a Java-based scripting language. We've got Spark R, we've got Spark SQL, and PySpark, which is a Spark-specific variant of Python. And these two are mostly used by data analysts, and some prefer SQL, some prefer Python, and there is no restriction of that, so you have freedom to utilize whatever language that you are comfortable with. So, and Apache Spark in Microsoft Fabric, how it is designed in Fabric. So each workspace in Fabric is assigned a Spark cluster, and it can be configured. It is pre-configured, and there's a recommendation that the default configuration is good for you, but however, you can configure that for your needs and just to meet your requirements. And for this reason, Fabric admin can configure that, who has access to the admin center, and it can be configured in the workspace settings from the section of data engineering or science. And what we can configure there is basically in 4 sections, which is pool of the Spark, that is going to talk about the node families, how many nodes we're gonna have, and what is the size of nodes. The nodes, just remember, was related to the let's say count of processors, right? Count of computers that we're gonna have in a cluster. And about the environments, we can just configure what version of runtime should be utilized when we are, as a basically default runtime version. And we can just configure the high concurrency that it is basically related to the notebooks, and when we want to execute some cells there, and when a session is going to be started. And this concurrency, basically high concurrency, is basically helping us to just minimize, to reduce the waiting time for a session to be started, for an execution of notebook to be started. And we also have the opportunity to log the parameters and the log metrics, whatever that is related to the notebook, automatically with no one line of code. So let's have a look at that one. And let me just bring up my nice Fabric portal. So as I mentioned, we have it in the workspace, right? And so let's move to Synapse data engineering. Let's create, or not, I already have a workspace here. I just want to check where we can do that configuration. So in workspace, the workspace setting, you can just find it underneath of the data engineering, data science, and then Spark settings. As I mentioned, you can just configure pool here. You can choose the pools or available pools, or even you can create a new pool. So even for a new pool, you can determine the size of nodes, how many nodes are going to be there, and for scaling up and scaling down, how many nodes are going to be added, and how it is going to be activated. So the default one is good for us, which is a memory optimized node family. And for the environment, as I mentioned, we have the runtime here that you can use for your purpose. For example, the version of Spark 1.3 is still in preview, so it is. We can just let it to be generally available and be released in final version. And about the high concurrency, it is just on and off for now. So you can just configure it like this, and for automatic log is also on and off. It's back to the slides. So yeah, we are good with the configuration of Apache Spark. About libraries in Apache Spark. So we mentioned that Apache Spark is a programming framework, right? That we can code there. We can write the codes there. So for those who are not familiar with programming, world or programming environments, you have no background of programming, I should say that the libraries are basically a collection of pre-written code that you can actually use to perform some specific tasks. It is going to including some functions or some functionalities, some procedures to be utilized within your code. You have to import those libraries sometimes, or sometimes it is already loaded into your framework. And the other thing that I want to mention here in Spark, actually, it already have a wide range of wide selection of libraries that are commonly used in performing the tasks. So especially for Python, that is, the Python libraries, most of them are there because we have PySpark in our framework for processing. But in Fabric, as I mentioned, we have, by default, we have some built-in commonly used libraries. That's fine. But if you would like to have more libraries, and you want to have additional list of them, then you can just add them to your code, right? But we have two type of additional libraries that are going to be added. Some of them are the public, that are publicly available, from some repositories like PyPL or Conda. And you can also bring your own library that is written in, by yourself or by your company, or a trusty one that can be also added here. So for this reason, you have to create a new environment and or modify an environment to add those libraries. And it has to be in these formats of, for example, .jar or whatever format that is acceptable for custom library. When it comes to the execution of code in Spark, actually in Fabric, Spark in Fabric, we have two options. Option number one is Notebook, where basically you can, create a piece of code or pieces of code to interact with your data. You can work with your data and analyze that. what actually a notebook can do is that you can combine text, images, and code written in multiple languages, as we mentioned before, the languages that are available in notebook, and just interact with your data. And this code that can be added to a pipeline and to be automated later. And also I should mention that a notebook can have one or more cells. Each cell refer actually to a piece of code that can be separated from each other. And those cells of codes or cells of can be, those cells can be in two shapes, which is a markdown formatted. It is basically for commenting, and the other one is executable code. And so that executable codes can be executed in different modes that we can see here. And we will just jump into the notebook to see that it can execute only that specific cell, or the cell above that, or from that cell onward, and or even you can just select a select a specific piece of that code, or even you can freeze that code to not be executed. So you have flexibility of how to execute your code there. Let's have a look at that, and let's create our first notebook here. In my workspace, let's have this workspace here. From here, I'm in data engineering. I can just create a notebook. So the notebook environment looks like this. You can just add your data sources here. The code can be added here, or you can just add a code or markdown in the bottom. Even you can just change it to a code from this section, or from from code to a markdown. And in order to execute the code, you can just each of them is called a cell, right? And you can add your codes in a there, or even just move them around. And for running a cell, you can just, as I mentioned, you can execute that specific selection, or if you just hit the run cell, it is going to only run that specific cell. But if you want to run everything, for example, run this cell and all below, or run all above this cell, and then you can just use these options. Let me delete this one, and we will talk more about this. Just feel free to ask your questions. If you have anything in the chat, I will answer them at the end of show. Cool. The other option for running Spark code in Fabric is Spark job definition. So the first type was creating a notebook that you could just interact with your data by writing the codes and having those cells. But in another type of that type of execution of code is Spark job definition. When, for example, in the scenarios that when you want to ingest and transform data as part of an automated process, you can use the jobs in Spark to be executed on demand, or even by schedule. Sorry. So this job actually a Spark job can be configured when we are creating that. The file types that is available now that you can utilize for being executed is in Python format. So, and there is a limitation of size of 250 megabytes, and basically that file can be uploaded from your local computer, or it can be referred to a Azure Data Lake storage account, and that's provide the path. And even you can even you can have your actually reference files, and actually reference your lake houses, what lake houses are going to be actually to work in the in that job definition, right? So let's have a look at that one and see how it does look like in a workspace. For Spark job definition, we can just give it a name. Let's say DP-600, and session 2 Spark job 01. So let me just bring some comments here. Javier, hey, welcome. Thank you very much. And as is how to insert images in the notebook. So as you know, we can load the the files or images even into our whatever file that we want, that we can load into our lake house. So, and that lake house is going to be available in our notebook. So later we can just load some, but we are not going to process them, but because which is not available in this course now. But however, we can load them and access them there. Even we can just find a code together, right? We not if we have time, of course. But thank you for commenting. So for job definition, for Spark job definition, as I mentioned, you can just upload a file, local file, or even providing the Azure Data Lake storage path. You can have the main files here, and you can also reference a file when that file is already referenced in this main files, and if there is any lake house to be linked to this execution of code. Cool. The actually code syntax is in Fabric, basically for Spark. As we mentioned, we can just write codes in Fabric in different in Spark in different languages. So what are the available items here is PySpark, which is Python. We can have Spark SQL, Scala, which was Java-based one, and also a Spark R. Let's have a look at that one and see where we can find it in Fabric. So for each cell, actually for the whole notebook, we can specify what language we are going to use for. And when we change that, it is going to, as you can see, it is going to change its, the code appropriately. For example, in SQL, for commenting a line, we use, a double dash, or for example, in PySpark, it is going to utilize the sharp for commenting. So it is very useful here. And As we notice that when we change a language, right, on top, it is going to be applied for all cells, right? And we can change it from the bottom, right, to specify, for example, this cell should utilize what language to be executed. For example, for the first one, I say it is SQL. The other one is going to be Python. However, as you can see, it is, if it is going to be different than the notebook default language, we will have something like this, which they call it magic, that you can basically changing the language for cell in your notebook by using magic. The magic for PySpark is percentage, percentage, and then PySpark. For SQL, we have the same thing. For actually Spark SQL, we have the SQL, and Spark for Scala, Spark R for Spark R. Before jumping into notebook and doing the actual, work with the data and transform that, analyze it, let's just see what are the data structures in Spark. The first data structure in Spark, and which is the native data structure in Spark, is called RDD, resilient data, distributed data set. We can work with that. We can directly work with that, but some data analysts most of the data analysts prefer to work with data frame. And the course that we have from Microsoft Learn is talking also about data frame. Data frame is provided by Spark SQL library, and is going to work with structured data. And we also have pandas, which is provided by Python libraries, and which is similar to data frame, but in some cases we have to utilize pandas. We will see that later in the course. And we also have data sets, which is also provided by Spark SQL library, but but it is supported for Java and Scala. So we talked a lot. Let's do some practical things and have some hands-off experience. The first thing that we need to do is loading the data into a Spark data frame, and just see how it does look like. For this reason, in the module, we have a set of files, the 3 files that, as you can see, in order to work with the data, of course, we need to load that data in the lakehouse. So the first step for us will be adding a lakehouse if you have no lakehouse there, and then you can just load your files in there, and then we can just work with those files in Notebook. So let's jump into there. I would like to create a new lakehouse, and let's just start it from scratch, right? Let's call it DP-600 Lakehouse 02 for session number 2, and let's create it. Cool. Let's upload some files there. Before uploading, let me create a subfolder, and let's say data, and another subfolder. Let's call it orders. And for the orders, we can just do the upload files from the local. I've got my files here, which is a partition, partitioned files provided by Microsoft Learn. files are already uploaded here. The next step for us, and let's just, if you want to have a look at the data, how does it look like? It is a CSV file, and yeah, let's create our notebook. Just start working with that data. Cool. It is the notebook here. We can add our lake house, right? You can add it from top or from bottom. You can add a new lake house here, or existing lake house. For the existing lake house, you can just have a selection of lake houses, but I will select the current one that we want to work with. And as you can see, we can load, actually see our data here. And as is for your question, you can just upload an image here and see, and just work with that. If you have any scenario to work with images. So yeah, we have the data. Let's start with this one. It is, let's say it is the start of notebook. Let's make it as a markdown. And for the code, let's just let me copy my code here. So here, in order to load the data, we need to read that data. We need to specify what format it is. So, for example, there is a data frame. We call it actually df here, which is a variable for the storing the data, right? It is a CSV. In the options, we say header and true. Actually, which means that use the first row of CSV as the header, the column names, and it is going to be loaded from this path. But my path is a bit different. Let me just modify it. It's from orders and CSV, and then just execute that. It is going to be loaded in this data frame, and with the function of display, we can display that. So everything is loaded, right? And as you can see, I wish it is not that small. Let me see if I can make it bigger. So as you can see, the column names are not right? There is no column, header for them. So instead of having this, header true, we can just say header false to not considering the first row as header. But as you can see, it is basically giving a default name C1, C2. It doesn't mean for us. What we can do here, let me just back to my slide to not just make sure we're following that. In order to, giving a schema, giving a header title, or sometimes we are not happy with the header titles, we can just change them, or specifying a schema to that. For this reason, we can just have this code here. Let me bring it up. And in order to load the data. We can utilize this, structure type, right? But let me change my. Just notice one thing. The SQL data types are not available by default in Python, right? And we have to import them from this library. It is one one of the usage of the libraries in Spark. So we can just import it and make use of this structure type, and basically from this SQL types. And it is going to give it a name for each column. And in the schema section, we are just referring that order schema that we defined on top. For example, for the quantity, we are using the integer, or for item, we are using string. For text, we are using float, and also for the price. And the data is loaded now, and we can see that each column has a specific name, which is basically the name of columns. Okay, before working with the partition data, I would like to just mention something here. We basically loaded everything, right? But if we want to just limit that, the values that we are seeing, we can use a function of limit, right? Let's do that here. Here you say limit and only 10, first 10 rows from that data frame, and not loading everything. We only want to, for example, make a sense of data. So we only just get a piece of that, which is the top 10, for example. So we have loaded the data for 2019, right? But as we can see here, we have a partition data for 3 years, 19, 20, and 21. When we want to load that kind of data, the partition data, we can we can just say, instead of the file name, we can just say star whatever CSV files that are in this folder should be loaded in this schema. It may be, the data may not make sense, right? It is going to give you error if they are not in the same, structure. If we specify a type, and maybe it is going to be there, but giving you the null values. But here we've got everything there, and everything is in the data frame, but we are only showing 10 of them. So if you have no idea what the partitioning is in data world, in the data structure, basically it is a way for just separating the data from where they are going to be stored, and it is mostly a useful technique for analyzing data and analytical data. When, for example, you specify a year in a partition that you're not going to utilize that partition a lot for the year of 2019, and when you want to use that, it's going to read the data from that partition specifically. When you're just analyzing your data in the current year, those data is not going to be explored and it is not going to be touched. So you're gonna have a better performance with partitioning. The next step here for us is to explore the data in a data frame. So we have already loaded that, and but we can just see how does this data look like, right? In order to this one, for example, we can just get a piece of that data. For example, I want a list of customers, right? That is going to be, I'm selecting some fields from my data frame. There are available fields here that we specified previously, and from those names I'm selecting customer name and email. So I can even print here in the result, and using the functions like counting the customers, right, or counting the distinct list of those customers to give me a unique number of customers. Let's see how does it look like. So we have, totally we have 32,000 and something record in that data frame, but the distinct list of customers are about 12,000. And of course, those 12,000 items are already loaded here. You can download them, or you can just have a look at those data. The next item, is that here, you can basically, read your data in the other way, right? You can read that in this way. That is, specifying the fields. It is a shorter, type of, coding, and you can also utilize the, functions like this for selecting a, list of columns. And also we can add the filtering, can by a where clause or where function here. Let's have a look at this. So here, as you can see, we can select that in the other way, the same columns, but we are adding a condition where the item is like this, right? And now give me the number of customers and the number of distinct customers, I mean. So the next option that I have here for aggregating the data, we are just exploring the data, right? You're exploring and seeing what kind of data, what kind of information are already in the in our basically data frame. So in order to aggregate that, let me bring it up. So to aggregate the data, we can add a piece of code here, which is basically selecting from that data frame what columns. Here we are just talking about the the count of items that were actually purchased by customers, and we are going to have a summarizing, just having a total of them, which is going to group by items, and then display that. So basically, when you want to work with a data, firstly, you need to just get a sense of that data by aggregating them, by having a basically having a look at that data from different aspects. The next item that I want to talk about is some specific functions that can be added by added to the code by adding the libraries. For example, here, like the function the function that we have here is, for example, we want to get the year of a date value, a full date value, which contains year, month, and date, the day actually, and we want to only extract the year value of that. So in order to use that, or using the other functions, we can import this basically this library, and that data is going to be available there. Even we can just give it an alias, right? For example, the alias of year. For those who are familiar with SQL querying, the aliases are very useful for naming the columns. So let's jump into the transforming the data in Spark, right? When we are talking about the transformation of data, it means that the current status of data that we have, now is going to be somehow changed. For example, we have first name and last name in one cell, right? We have a full name of customers. So we want to just separate them to first name and then last name, two separate columns, or vice versa. We can may have both of them in separate columns. Then we can just concatenate them. Or as I mentioned in the previous session, I think in order to transformation, you're getting the data from different sources. Let's say from source A, the gender is going to be specified as 1 and 0, while in the other source you have that gender as M and F and whatever, right? So in order to transform the data, we need to just make them similar and having the same definition of gender value. So here in the notebook, we can just do the transformation and prepare the data for a better analyzing and a better actually visualization. So let's look at this guy where we want to, I'm just adding the codes to the cells and in the same notebook, right? So again, the library of SQL functions is going to be added here. To the data frame, and there are lots of functions that we can use in our data frames, right? In order to add a new column to the data frame, we can, the Spark data frame, we can use the function of with column. So the basically this with column is going to have some parameters or arguments. So the first one is going to be the name of that new column, the value of that new column, then the value of that new column. So we have the year, for example, or even another column that can be added next to that one, which is going to be month. And even, as I mentioned in my example, we can, let me just bring it back to see a better, of the code. For the first name and last name, we can create the new fields, from the existing field. And for here it is, for example, splitting the customer name, and that delimiter of basically customer name is a space between the first name and last name. It's going to just assume it like this, and getting the first item for the first name and the second item for last name, and of course the count of actually the numbering of the indexes in this array is going to be started from 0. And we have actually our transformed data frame, and then we can just select a specific fields, right? Everything is there. For example, the customer name is still in our data frame, but we don't want it, right? We only want, we want now the newly created fields here, which is the first name and last name. And we are not going to, choose that in our new data set to be, displayed or even loaded into our transformed data frame. It can be basically we are replacing, we are overwriting whatever that is in our transformed data frame. And automatically that customer name is going to be out of our data frame. So if you would like to learn more about the data frames and how work with them and knowing the basically the functions and capabilities, you can just follow this link. And so the data is transformed. We need to save that, and after that we can just load them to and from the Parquet files, right? So let's see how it is going to be stored in Parquet files. Let's add another code here. So this transformed data frame that we have, we can always refer to the data frames that are already in the current session of Notebook, regardless of what cell, because all of them are somehow, connected to each other. So the transformed data frame, we can use the write function here. The mode is going to overwrite whatever that is in the in our lakehouse. And here, let me just say data and orders. Yeah, let's not the orders. Let's have it in the transform data and orders. Yeah, that's fine. It is going to firstly, only store the data in the Parquet format with this Parquet function. And we've got the print, actually printed message transform data is there. Let's quickly refresh the files. And in the data, we can see we have now a folder of transform data and orders, and we have these 3 Parquet files. So a question for you. Why we have 3 Parquet files? We didn't partition that, right? But we have 3 Parquet files here. You can just write in the comment and we will just answer that later. So let's back here. The data is loaded. Sorry, the data is saved, and if we want to load that data, we can load it again actually to our notebook, or it can be even loaded somewhere else, right? We create a data in one notebook, and then it can be utilized by other notebooks by our colleagues. So let me bring it up. In order to load the data, can use this. So for writing, it is writing. For reading, we are reading the data. We are specifying the format. Previously, we specified the format of CSV, and here we are loading the Parquet data from this folder, right? And everything is going to be loaded in our orders. Oh, sorry, let me use my awesome. So yeah, for the question that they asked, Javier says the Parquet files are defined with a fixed size. Yes, and the other answer can be like this. We mentioned that Spark is working with clusters, right? And basically, when it is working with the clusters, it means that it has various nodes to work with the data, right? And each of these basically files are being created by a node, right? That is spread within your cluster. So it is good to know that how Spark is working, right? And how this spread and distributed processing is helping organization to have a better performance. Just of course, if there is a limitation for size, but there is a best practice for the size. But it's good to know that how the distributed and no processing systems are working there. There's a question from Aziz, in between. Is the code PySpark we are writing here the same as in Python, or would Python code be different? It is somehow similar. I'm not Python developer, right? But Python is basically the syntax would be similar, of course, but in terms of the libraries or sometimes functions, it's going to be different. For example, the data frame is a Spark data frame. In Python itself, we have to just import that, of course, right? I hope I answered your question. So let's go to the next slide that we have for saving and loading the partition files, right? As you can see, we have everything in one place. So what data that we have loaded, just let's recap it. The data that is loaded in the data that is loaded in this, actually that's saved in this Parquet files, or everything, right, from 2019 to 2021. But we would like to do a partitioning there, right? Let's just write the data in a partition way, right? And here we can say, let's just follow the same. Yeah, let's follow the same URL that actually we were loading. So in order to load the data in partitions, we need to just again save it in the partitions. I mean, we need to use the write basically function, then the function of partition by. The partitioning can be done by one column or more than one column, whatever that is, based on your scenarios and your strategy of the data and how you're going to report them, how you're going to access that data. So it is very dependent on your scenario. But in this case, it is just partitioning them in the year and month. So, and it is going to be in this partition data folder. And after loading, we can see just let's wait question as well. What level of proficiency must we have to pass this DP exam? I think it is my feeling, right? We can just research more about this question as is, but I prefer, I assume that only the section of Python that is related to the data analyst, right? There are some courses for Python, Python for data analysts. It is not a full, package of Python. You don't have to, for example, learn how to create the APIs, right? Or writing or working with the databases or whatever, something like that, right? In Notebook, you're working with the lakehouse. It should be very quick. It should be very simple like this. You're transforming the data, you load the data. Just let's think about some scenarios like this, right? What kind of complexities are going to be involved in your transformation process, right? So we can just think about that in your current projects or the previous projects that you have been involved. Then yeah, it is the same thing that I know I'm explaining actually. The PySpark and Python, it doesn't matter. It means I know what I'm trying to say is that you have to just learn about Python and PySpark, whatever, and for data analyst, right? Not a full course of that. I've seen a course for Python which was 50 hours, right? But for a 15 hours or 15 hours for only data analysts. But it is very that course for the data analyst is very specified and very for some some specific things to do. But with the basic stuff like this, we are good. But you can just think about that and see what is your scenarios and what we can do. But for the exam, we can just research about that and see in how deep we are going to be for Python language. So the data is loaded. Yeah, awesome. Let's back to the course and to the topic. So we were loading the partition data, right? The partition data for in the Parquet format, and it is going to be partitioned by year and month. Let's just refresh my files to see the data there. So while this one is loading, and let's check. Okay, the next section for us will be that. It's still refreshing. Let's refresh the if we refresh that, we have to. That's good. We can execute the whole items there. It is connecting to your last session, which is good. It happens. The partition data, we can see the partition data here now. That we have the year and month. You can see for each month, for example, we have a partitioned, data here. And when we want to just imagine how efficient it will be for reading the data, we want a data for 2019, for example, the month of July, then it is going to directly to that folder, then month of July to read the data, and it is not going to touch everything, right? That is a fantastic thing. So I'm not sure if my data is already there, but let's just check something. It is, when I just reloaded everything, right? Reloaded the page. I want to check if the data is there. So here in this cell, we have no loading. Let's see if it is working. Awesome. So even with refreshing the whole page, our session was not wiped out, right? And the data is already in this data frame. Fantastic. I like that. Okay, Aziz, awesome. Cool. We save the data in the partitions, and now let's just load that data. In order loading the data of the partition, as I mentioned, we are going to be specific on something, right? For example, here, we are going to load only the data for 2021, right? And in the basically the folder path that we are going to just read the data from, we say year 2021 and month whatever. Instead of 2021, we can just say star. It means that just go and load everything. Star means everything here. And of course, we can just limit that data. It is loading everything here for us again. Cool. The next section we have here is working with tables and views with SQL, with Spark SQL. So as I mentioned before, some data analysts prefer to use SQL rather than Python. They are more comfortable with SQL. But of course, there are some, there are some, limitations, right? And you have more power in Python. Of course, you need to have a knowledge of Python to store the data and to do your transformation sometimes. But in the other side, you can also utilize your SQL. That SQL can be executed as part of your Python, that you can just pass it as a parameter to your Python function, and even you can just write it as is and execute it as is. So basically, a meta store, as a meta store, it is provided by Spark SQL that we can create the relational tables and views. And this, Spark SQL, as we mentioned, it is supported by supporting this SQL statements. And here you can just combine, the flexibility of data lake, of having different data, and also the structured, data using SQL, which is fantastic. You can combine whatever that you are reading from CSV, just put it in a view or something, and then from there, just combine it with the other tables. It's going to be fantastic. And basically, tables that we are going to create in Spark are going to be stored in our lakehouse, and there is an option to just save it externally, right? And so the tables can be managed in the lakehouse or externally in the other, and the files basically are going to be stored in your Azure Data Lake storage, for example. If we want to save it as a table, right? Save a data frame as a table. Let's go to our notebook and let's create a table. So the format will be Delta, which we discussed in the previous session, and we are going to just save it as a table. The table is going to be called sales order, and it is there. And as I mentioned, we can basically load the the data and utilize the SQL syntax within Python by just passing that to the function of SQL here. So let's see. The data is now saved as a table. Let's just refresh our table and see what we've got there. As you can see, we have the table, the columns, and the data can be basically retrieved, right? We can read the data from that table. So in order to do that, we can just write a query like this. It is in the Python language, and we pass the SQL script there. We need to specify the lakehouse. Our lakehouse name is DP-600 lakehouse 02, and there is a limit of 1,000. Let's just make it 10 and hit it. The data is loaded here. The other way of we can even use the SQL itself, right? SQL language itself, and not involving with with Python. So in order to do that, we can just write it like this. As you can see, as I mentioned previously, we can use a magic there, right? The magic that is going to change the language. In the previous one, we had Python, but here it is going to change the language to SQL. And directly we put our SQL script here, and we can see the data. The other option that we have is basically we can create the views, the temporary views within a notebook, right? So, and those views are temporary. After that session, it is not going to be stored in Lakehouse like what we had in data tables. And so we will have the temporary views and just work with them in the current session of the notebook. And just after stopping the session, it will be gone. One thing about the tables, when we create the table, of course, that table is, we explained that before, in the previous session. But just a reminder, the tables are an abstraction for the Delta, files, right? And we need to just keep in mind it is not actual table, and it is very optimized one, and we have an abstraction of table on top of those Delta files. Let's back to the creating a view, and for the view, let me C, create or replace temp view. Let's say df dot create. df dot create or replace temp view, and then let's call it temp view. Right? We are just creating that. The view is created, and I will add a piece of code here. Let's say magic SQL, then select star or star from that temp view. Let's see if it works. So it is a usage of temporary views. So we have worked with the data and in both languages of Python and SQL. Now let's just do some exercise on how to visualize the data. So there are basically two types of visualizing in Notebook. You can see, in Notebook, in this data engineering, we even don't need Power BI, right? We can do whatever that we want in Notebook. We are loading the data, we are transforming that, we are making use of the lakehouse. We can create a new lakehouse, and we can then, visualize that. So, which is also a good thing to have in order to, utilize the built-in charts. For visualizing the data in Spark, we have two options: the built-in chart, and the other one will be by using the code of Python, and then we will just discuss that later. Let's just try the first one, the built-in. We use the SQL, everything from the sales orders, whatever that we have, and then instead of seeing them in the table, we can just seeing them in the chart. But it doesn't look right? They can just customize it. We can keep it as bar chart. And for example, the key is going to be item. The value that I'm going to count is quantity. And let's just have a summarize some of them. And we will have a nice chart here. The built-in charts that we have in Notebook is very limited, very basic one. If you want more fancy stuffs, you can just make use of the libraries. For example, the first library that we will have a look at that is the library from Python, which is called matplot library. It is plotting library that you can just have some, you need to just code there to show that, chart. So let's check it out. There. The piece of code that we have here, we have the SQL query. It can be a variable like this, and it can be shown here. The data is going to be shown like this. It doesn't look right for us. We would like to have it as a nicer one and just visualize that. Let's add another code. Here we are using basically we are using the library of matplot library. We are importing that, and it is called plot, and it can be referenced within our code. In order to use this matplot library, our data frame in Spark doesn't work for that, right? We have to utilize pandas data frames that is provided by Python. So in order to do that, we can just convert the data frame that we already have on top, data frame for Spark, then we just change it to pandas. So it is going to be called data frame cells, and from plots we can create a bar chart, and we are specifying some x and height, whatever that is related to a bar chart, and then we're gonna show that. It is at this stage it is very basic one, right? We want a nicer chart, right? Nicer figure. So we can have this code here. Again, it is importing the library. This plot, can be basically cleared, after each, execution, right? Or before each execution. It is the basically it is the the function to clear the plot itself, this plot. And we've got the plot bar chart, and we are going to make it nicer. We are giving it a color example, and also we are customizing that chart by adding a title to that, by adding labels to X and Y. We are adding the grids there, and also some configuration related to the grid. And also we have a rotation of these sticks. It is getting nicer, right? We can also make it nicer and create it as a figure, right? So if we want to make a figure here, we can utilize a function called figure, and we will give it a size with the same configuration that we had in the previous code, and it will be a bit wider and nicer. The other option that we have here, we are just working with this library, right? And see the functionalities of this specific library. Of course, for each library, you can just go and read about that library. It can be something else, right? From your custom libraries that you have written or your company has written for that. The next one, in that figure, we are going to add another chart, right? Which is going to be a pie chart, for example. We're gonna have, we're gonna have the subplots for each, plot, and the first one is like what we had. It was the bar chart. For the second one, we are just getting the pie chart, and we are adding, the elements of that pie chart there, and then after that, the plot itself is going to be shown here. Cool. Let's back to the slides. So we've covered them, and if you would like to learn more about this, basically library, you can follow this URL to learn more about that. There's also another library which is called Seaborn, but that is basically abstracting that matplot library. We had to write some codes there to customize that, to make it nicer, right? But Seaborn just abstracted that. They worked on that library and make it, more comfortable for basically data analysts to write less code. So for this one, let me just copy the code. And as you can see, for the bar chart, it is only this, right? And it is nicer. It is going to, if it loads, it already has the the titles, but in default and as is default, right? If we want to make it nicer, we can just add to that, right? For example, we can just set a theme for the white, to the grid, or we can just have a grid on behind the bars. Or the next one for me will be this guy, right? That we want to create, for example, a line chart, and you have more. It's going to be more efficient in terms of saving time, and with less knowledge of coding. So it is going to do it for you. Yeah. Cool. So you're done with working with the notebook. In order to save that, it's already saved, but if you want to have a nice, a name for it, it can be DP-600, DP-600 notebook, let's say 01 example, and wherever you click, it's going to be renamed, and it is there. And if you want to stop the session, stop the Spark session, you can just come here. You can stop the session from here, or from run, you can stop the whole session. And it is stopped completely. You can close that and just see what are the items that we have created in our workspace. Cool. And the knowledge check. The knowledge check. Let's go for this. In the meantime, I will go through the question if there is any. Aziz, can we save this temp view as a permanent to use it later? It's a good question. So I think the views are. Let's just check the functionality of that, the purpose of that, right? The view is in one session of notebook, right? And you're working with that view within that notebook. If you would like to have that data somewhere else, I think it is better to save it as a table and then just reference that. I'm not sure if you are, you would like to use that temp view in other notebooks or not. I'm not sure. Just make it more clear. But that temp view is available in that item, in that notebook, I mean. Yeah, Shanti, 1C, 2A, and 3C. Awesome. Any more answers? Javier, A, C. Cool. So the correct answer is CAC. So it means that when we want to when you want to basically write a code and interact with your data within Fabric using Spark, you need to create the notebook, right? The notebook gives you the opportunity to work with the data, and as we experienced interactively, we are just working with the data. We see that we can just exchange it, we can transform it, we can see it as a chart, and it can be downloaded. Everything is happening in one place, and it is interactive. For the second question, in order to use a CSV files, right? CSV file without loading that in your table, right? So it is better to just load it in your data frame, work with that, transform it, or even explode it, or even save it after that in a table or another file. And the method actually that is used in Python and PySpark in order to load the data, across the folders and actually partition them, we use the partition by function. As is to your question, that how deep you should be in PySpark. So as you can see, the questions are shown here. I will try to find a course for Python specifically for the for this data analyst section, and we'll share it with you. Awesome, thank you very much, and congratulations, guys. You've completed the third module of this learning path. Use Apache Spark in Microsoft Fabric. You can share it with your network. If you have if you have already done it, just mention me there. We can just celebrate it together. If there is any more question, let's see. Could you please elaborate again? Please. What do you mean by please? Can you make it more clear? Do you mean the plotting? If yes, just give me a hint. And guys, so we have completed the second session. Our third session will be 1st of June, which we will talk about the data lake tables. And just be prepared for that one. It's going to be a nice topic as well. And just make sure you follow us on in the LinkedIn. In the LinkedIn group, we can just chat more about Fabric there, and let's learn together and let's grow together. Introduce us actually to your friends and your network, and feel free to check out the YouTube channel, and stay tuned for next sessions and whatever updates that are coming from the Fabric. So if there is no more question, as is, I couldn't, I haven't received anything from your question. We can just, chat offline, of course. Just feel free to just send me a message in LinkedIn. We can just chat more about that. Thank you for joining, Shanti. Thanks everyone for joining, and for those who couldn't make it to attend online, it is just recorded and is going to be available in the YouTube channel. So Javier, one question before. On Saturday, I was trying to follow the steps, and it looked like the Microsoft Fabric environment wasn't stable at all. It was throwing errors when I tried to create a data lake, and then some minutes later, it was created straight away. Yeah, sorry for that. But in these cases, Javier, I basically use the in private or incognito sessions of the browsers. Sometimes it is going to be cached, and sometimes you have to, and you have to go through the in private sessions. As is, I saw a comment. Oh, okay. Let me back to my notebook. Where is my notebook? You mean this one? Plot CLF, right? So let me come up for this one. So PLT basically is an alias of this library of a library from matplot library, right? That it is an alias, the PLT, and for clearing that, so in order to clear the plot area, let's only execute this section, right? It is, it is basically clearing the plot area in the bottom of the code, and also it is clearing whatever that we have this in this plot, right? I wish I could find something here. Yeah, for example. Oh, sorry, I'm not sharing my screen. Do you see my screen now? Yeah, awesome. Thank you, Javier, for the heads up. So for that plotting, let me just explain it again. So the plot is this PLT is basically an alias for the library and function that we have, the library that we have imported from PyPlot, right? The library is called a matplot library, and we gave it an alias. And that alias is going to be utilized within our code. So the first function that we're going to have is clearing actually CLF, which is clearing the plot area. And the plot area is basically, we are adding the charts to that plot. It is a container. Let's say it is a container of our charts when we want to show them. The first chart, for example, here is the bar chart, and the second chart was the pie chart. And which is going to just clearing that plot, and we are going to start again. Because just keep in mind that when it is just because I stopped the session, it is getting a bit confused. Let's rephrase that like this, as is for you. The plot area is basically a container, right? And when we add something to that container, it is going to be added there, right? And in one session, in the whole session of notebook, that plot is going to contain those charts. And if we want to, if we keep adding to that, plot, it is going to, and every time that we execute this code without clearing that, all of these bar charts and pie charts are going to be added to that plot. So we clear that, and to just show that specific, part that we want. Let me just give it another example. Let's say you want to have 10 plots in one, in one 10 bars in one plot. You can just add it top, and all of them are going to be added there. I hope I answered question. Oh, my voice is not clear, or sorry. Let's. Does it mean that my voice doesn't come through, or if everybody can hear me, please let me know. However, yeah, I hope I answered your question, and I will write it in the chat for you in LinkedIn for you as is. Don't worry about it. And thank you very much for joining, guys, and see you in the next session. Take care.